Alright, this is Zihan from Zirconium Academy of Education. Today I'm going to do a demonstration on question 4 from the sample Leaving Cert exam paper of applied math. Now we are going to start from the first part of question 4. A ball is projected from a point on horizontal ground with an initial speed u and at an angle alpha to the horizontal. The ball reaches a maximum height of ho above the horizontal. Upon landing, the ball bounces with a maximum height of h1. The coefficient of restitution between the ball and the ground is e. First question, calculate ho over h1. To think about this question, you have to consider the moment where the ball actually lands on the ground. And the process actually going on here is the ball is falling like this and then bouncing around from the ground like that. So at the moment where this happens, actually it indicates a change of velocity of the ball itself. From the previous lessons, we know that the coefficient of restitution in this case only works on the y-axis. And this is a very basic assumption we are going to make here. So if you think about this, then the ball's velocity can actually be separated to two different directions. For example, if the ball lands on the ground with a speed of v1, then we can dissociate v1 to v1x and v1y. We can do the same thing for v2, which is the velocity gained by the ball after the bouncing. So v2 actually has a direction like this, and then we can have v2x as the x component of v2, and we also have v2y as the y component of v2. But here the question is, there is no angles and there is nothing is actually known except ho, h1 and the coefficient of restitution. So the question here is actually now transfers to v1y and v2y. Like I said, this is because the coefficient of restitution only works on the y direction. And then from the formula of E, we know that it's given minus E is V1 minus V2 over U1 minus U2. So in here, if we treat the ground as one of the objects here, let's say the ball is object 1 and the ground is actually object 2, then object 2 is not moving at all. Thus, in this case, we have V2 and U2 all should be 0. And this is because the ground is not moving. So following this, we know that in this case, we have minus E is actually V1y and v2y, the relationship, as actually v2y over v1y. Some people may ask about this minus mark. Well, this minus mark actually indicates the change of direction of the speed, because if you think about it, it's coming down this way, but it bounces off this way. So because you have a direction change, so that's the reason why you have the minus mark here. Now, knowing this, then there has to be something to do with the height of this question, right? So if you think about height in the y direction, for this type of question, there should be another formula that comes to your mind. And the formula is v squared is u squared plus 2as. And generally, we use this formula in a lot of motion questions. So for this question, if you think about the falling process of the ball from the top of the first curve, which is here, to the bottom where it lands on the ground, which is the one position, which is here. If you think about the whole procedure, then you find out that it's actually falling down by height of HO. So in this case, if we consider in the y direction, then the ball is falling with a Vy 0. And the reason why that's the case is because at the highest point of any projectile, the velocity of the ball should be directly to one direction. So which means there's no y velocity at the highest point here. So that makes u as 0 if you think about from y direction, right? Remember, you're not taking x direction into consideration. And the final velocity is where the ball lands on the ground, but it's only the y portion, the y component of the final velocity of v1 is actually. So in here, you should use v1y instead of v. So v1y squared is actually 0 squared plus 2as. Now here, again, in this type of question, you got to think about is plus or minus. So generally speaking, you give yourself a limitation at the start of the question. For example, you name downwards as positive. Then anything towards downwards is actually positive. Now, this is only an assumption you make. You may find out any assumption. For example, you can use upwards as positive. It doesn't matter. But just keep the assumption for yourself, and you are going to use it along the question. Now, because we are using downwards as positive, so in here we have plus 2 times g times HO. And that's because firstly, v1y is pointing downwards, so it's no minus v1y. So it is positive. And the u, we took it as 0, as we discussed. And g is actually acceleration due to gravity in this case. And this is because anything is falling. It's basically anything is doing a free fall. It has an acceleration of g. And for a deeper reason of this, you got to think about Newton's second law. In this case, we only assume that there is only one force acting on this acting on this body, which is the weight of itself. And it is given by the formula m times g. Now this acts as the net force applied on this body. So according to Newton's second law, it's basically mg equals to ma. And now these m cancel out, so the acceleration of the ball is given as g. Notice that this is a very ideal assumption, because in real world you will face air resistance and something like that. But anyway, let's just go back to this question. So this is where you find the first formula relating v1y and HO. Now you are going to do the same thing for the second part of the question, which is the H1 part. So now think about the H1 part. Again, you're taking downwards as positive. So can you not make the same formula for the second bouncing process? Well, of course you can, because when the ball reaches the highest point, here you always have Vy0, right? So in this case, here the y velocity in y direction is also 0. So you can make the same formula as what you've done for the first process. Now, the ball actually here starts from v2y, and that's its initial velocity. So you're going to write v2y square as the u square in this formula. And on the left-hand side, now you have v squared. Now remember, the final velocity is always 0, so it's 0 here, right? Now the v2y should be actually minus v2y. That's because we already assume that anything pointing down is positive. So anything that's not pointing down should be negative, right? In this case, it's actually pointing upwards, so it should be exactly negative. Now 0 is minus v2y squared plus 2g times minus h1, because it's going up from 0, going up for height of h1. So that's the reason why you are using minus h1 in this formula. Now carry on this calculation, you'll find that it's actually v2y squared is 2gh1. Now the question asks you to calculate HO over H1, but the only thing we have here is the coefficient of restitution. But that's quite enough, isn't it, if you look at this formula now. So HO over H1 can actually be written as 2gHO over 2gH1, because if you multiply the same thing for the numerator and the denominator of a fraction, the fraction itself would not change. So why not multiply 2g, and just to make velocity play something in here. Remember from the previous formulas, we know that v1y squared is actually 2gHO, and we also know that v2y squared is actually 2gH1. So the formula now becomes v2y squared on the bottom and v1y squared on the top of the formula. So this is actually something to do with E, right? Now, if you know that minus E is actually v21 over v1, is actually v2y over v1y, now we know that E squared should be v2y squared over v1y squared. Now, we are trying to find out v1y squared over v2y squared. So it's actually this formula. Now the way I'm doing this is basically dividing v1y squared for both the numerator and the denominator of the same fraction. And you'll find out this is actually 1 over E squared. Now this serves as the first part of the question. Let's just go back and have a general look about it. Now the question asks you to find out what's HO over H1. So the first thing came to your mind here should be something relates to height. The only thing that relates to height here is actually the velocity. And also one thing that's very important, which is the coefficient of restitution. E here is actually relating to velocities too. So that takes your mind to think about two things. Firstly, height. Secondly, velocity. So if you're lucky enough, you can probably come out these two formulas. But this general question actually appears in the past papers of applied math a lot. So if it doesn't come to you naturally, then please give yourself some time to do more practice, especially to do past papers. Now, that's the first part of the question. So the second part of the question, actually think about the bouncing progress following this. So it's basically asks you to find an expression in terms of E and HO for H5, the maximum height of the ball after it lands on the ground for the 5th time. You can actually think about this process from the second jump, which maybe makes things easier. So from here, we have H1, and notice that this is a completely symmetry process when you're considering bouncing problems. So when the ball actually lands in here, it actually has a velocity pointing downwards. Remember, we're only considering the y component, right? So its actually velocity should be like this, but its y component should be exactly the same as v2y in terms of its magnitude. So the third process happens, and you have h2 here. It's actually the same. You're considering the question. So let's think about this. If we name here v2y pointing downwards, and we have another v3y using the same way we think about the first process, we have a v3y pointing up, then its minus e actually is v3y over v2y. So here everything is just the same as exactly what we done here. Of course, we have e squared is v3y squared over v2y squared. If there's anything unclear, please pause the video and think about the process twice yourself. Hopefully, you can use the same way exactly as what I did for the first part of the question to derive such a formula. And you will know that every process is actually the same. It's basically repeating itself. So, from the first part of the question, we know that HO over H1 is 1 over E squared. And once you find out that these processes are actually the same, just repeating itself, you will probably know that H2 over H1 will give you exactly the same answer. It should be H1 over H2. And this process just keeps going. Like, for example, you have H2 over H3, exactly the same number. Now, this is just keep going, right? So from the first formula, we know that H1 is actually E squared times HO. This is because we do cross multiplication for these type of formulas. H1 times 1 is H1 on the left-hand side. HO times E squared is E squared times HO on the right-hand side. Now, following this, you can have the same formula here. H2 is actually E squared times H1. So now, hopefully, you just find out this is a geometric sequence, and you just keep going. And the geometry sequence actually has a ratio of E squared. Now, we are not talking about sequence in this question. Of course, we are focusing on applied mass projectile questions. So now, H5, hopefully you know that is E powered by 2 powered by 5 times HO. And this is because if you think about the formula for H2, it's actually E squared times E squared times H1. So H2 is actually E squared powered by 2 times HO. Sorry, this is HO here. And now H3 should be exactly the same. So E2, but powered by 3 times HO. And hopefully you can find not only H5, but if the process keep going, Hn is actually defined as this. But the question only asks you for H5. And H5 here is actually E to the power of 10 times HO. And that's the height of the ball after it lands on the ground for the 5th time. Right, hopefully everything is clear here. Now, if there is anything unclear, please just go back. Feel free to pause and replay the video for several times. But if you do have any questions, feel free to send me a message. Okay, so that serves as the A part of question 4. Now we're going to talk about B part. So in B part, we have two identical smooth spheres, P and Q, each moving with a speed u, and they are going to collide together. So the line join their centers at point of impact is along the I-axis. Now, before the collision, velocity of P makes an angle theta with the I-axis, and the velocity of the sphere Q makes an angle theta with the J-axis. It's nicely shown on this diagram. The coefficient of restitution between the sphere is E, where E is between 0 and 1. After the collision, sphere Q moves off parallel to the J-axis. The first question asks you to show that E is tan theta minus 1 over tan theta plus 1. So from this type of question, now the first thing you gotta do here is think about the collision process before and after. Now before collision, anything is shown on the diagram. P is moving with a velocity u with the angle theta to the x direction. Q is moving with, again, the same velocity u, but it makes an angle theta to the y direction. After collision, P will actually move still with some velocity, but here you got to take into consideration that the collision process only happens on the x-axis. And this says that anything along the y direction should remain the same. So if you think about the question from the first part, now before collision, you can find the y component and x component of the velocity for P. So x component here is actually u times cosine theta. Y component is u times sine theta. We're not going to use a lot of time to demonstrate trigonometry knowledge, but if you do have questions, please just go back and check these knowledge. So it's actually derived from the definition of sine theta and cosine theta. Right, we can do the same thing for Q particle. Now, Q particle has an x direction velocity. Remember, this is still u. So u times sine theta here for the x direction, u times cosine theta here for the y direction. Now, after collision, like I mentioned, nothing will change along the y direction. So P will still move with the velocity u times sine theta as its y component. And for the x component, from the question, well, we don't actually know what the direction it is, but it doesn't matter. Anything like this if anything like this ever appears in your exam, just make an assumption yourself and keep yourself constant along the question. For example, we are just going to assume that after the collision, P will move, still going to the right-hand side, because from the question, you can probably see that this side is longer than here. So we assume that maybe P is still moving towards the right-hand side. It doesn't matter. Again, that's because after this question is done, you find that, for example, if the assumption you made was wrong, then you find that it's a negative value that you find for your VPX. If that's negative, what is meant by that? If that's negative, that means it has to be in the other side. So don't worry about this too much. Now, let's just assume it's pointing towards the right-hand side. Now for Q after collision, from the question we know that is moving only along the J-axis, which is in the y direction. So it's actually u times cosine theta after collision for Q, because there's no more u times sine theta here. There's no more x component. Now, once you figure this out, you can probably just apply the coefficient of restitution formula. So in here, we're going to mark particle P as 1. So anything relates to P should be as with 1, with number 1. And anything relates to Q should be number 2. So now it's very clear that V1 and U1 refers to the initial velocity and the final velocity for particle P. So V2 and U2 are going to be the velocities of particle Q. Now again, remember, the collision only has effect on the x-axis. There's nothing to do with y. So in here, when you're substituting these numbers, now you gotta be careful, right? So V2 here is actually 0. The reason is because there is no x component after collision for particle Q, because it is said in the question. And minus V1 here. So V1 here is U times sine theta. Now be careful. Again, you are going to make yourself a positive direction. Don't forget about it, because it is so important. We are talking about vectors, so direction always comes into effect. So you can't just simply use a number. In this question, again, I'm going to assume that anything pointing right-hand side is positive, which means anything pointing to the left-hand side is negative. So we should have 0 minus V1, right, which is the final velocity for P, right, for P on the x direction. So it's pointing, as we assume, it is pointing to the right-hand side. So we assume that this is positive. So we simply write 0 minus VPX. And for the bottom part of this fraction, we have U2 minus U1. Now, U2 here should be anything before the collision for Q particle, right? So U2 here is actually minus U times sine theta. And the reason why it's minus is because we assume that anything pointing to the right-hand side is positive. Now, we always have U1 here. Don't forget about it, right? It's minus U1. So what is U1 now? U1 should be U times cosine theta. And it is positive. And this is because U1 is actually here. Remember, anything relates to 1 is P particle. And U means generally initial velocity. So U1 should be the initial velocity of particle P before collision. And also remember, we only take in consideration for the x direction. So that's the reason why overall you have a formula of minus E is minus VPX over minus U times sine theta minus U times cosine theta. So this is a little bit far away from the final answer. If you look at the question, it shows is you just say that you need to show E has a value of tan theta minus 1 over tan theta plus 1. So this is definitely not the whole story. We're going to find out there has to be something to do with VPX. We can't just leave it there. So the another thing that comes into play here is the conservation law of momentum, as it always play a role in such type of question. So before the collision, we can see from the picture above that before collision, again, we are considering the x direction, right? Before the collision, we have mass of particle p. Let's just assume that particle p has a mass of m. Mass of particle p times is velocity in x direction, and this is the momentum of particle p before collision, plus the momentum of particle q before collision, which is also m, and that's because in the question, it says here two identical smooth spheres. So if we simply assume that one of them has a mass of m, the another one should be exactly the same. Now, we simply assume that every particle has a mass of m. So it's m times u times cosine theta plus m times, remember, the direction should come to play. So it's m times minus u times sine theta, and this is because it's here. It's pointing to the left. So anything pointing to the left should be negative. Now, these serves as the total momentum before collision. Let me just write it down here. That's the total momentum before collision. Now remember, this is only for the x direction. We only think about the x direction. So it should be the same as the total momentum after collision. The total momentum after collision is given by m times vpx, and that's the momentum for particle p after collision, again only on the x direction, plus m times 0. And this is because after collision we don't have a x component for q particle. Remember, there's no x component here. It is 0. So from this formula, we derive that is actually m times u times cosine theta plus m times minus u times sine theta is m times vpx. Now, a good thing happening here is you can just cancel out m. So you don't worry anymore about what m is. You just cancel this out. So vpx should be u times cosine theta minus u times sine theta. Now we have vpx, so we simply substitute vpx to the previous formula that we have here. After this process, you should have minus e is minus u times cosine theta minus u times sine theta over minus u times sine theta minus u times cosine theta. Now, actually, you cancel out a lot of things here. So firstly, you can just make this positive and make this positive. This is because you times minus 1 for both sides of the equation. Then following this is E equal u times cosine theta minus u times sine theta over minus u times sine theta minus u times cosine theta. Notice that u canceled out, which is also good news for you because it's finally closer and closer to e and only theta comes into play. Remember, the question asks you to show that e is tan theta minus 1 over tan theta plus 1. So the only thing here is you don't have tan theta. Now, the way to make tan theta is sine theta over cosine theta. So for this equation, why not just divide cosine theta for both numerator and the denominator of the formula. So it should be cosine theta minus sine theta over cosine theta. And the bottom is sine theta minus cosine theta. It's minus sine theta minus cosine theta over cosine theta. So by doing this, here it should be cosine theta over cosine theta minus sine theta over cosine theta, and that's the point we're doing this, over minus sine theta over cosine theta minus cosine theta over cosine theta. And this actually turns out as 1 minus tan theta over minus tan theta minus 1. So this doesn't look exactly the formula it is given in the question, which is tan theta minus 1 over tan theta plus 1, but don't worry, you simply times minus 1, again, for both sides of the equation. It's actually for the numerator and the denominator. So then you find out it's actually tan theta minus 1 over tan theta plus 1. And that serves as the first part of question B here. So hopefully you should have no question about this. Again, feel free to pause the video and just look back. So now, after all of these discussions, we are going to talk about the second part of the question. What if 25% of the sphere's total kinetic energy is lost during the collision? The question asks you to calculate theta and E. So in here, you should fully utilize the new condition that's given in the question, which is 25% of the total kinetic energy is lost. Now, the reason why there should be kinetic energy lost is because every collision should have some you may hear a sound of it, where some of the energy will actually convert to heat energy or any form of internal energy. So energy loss is kind of normal and inevitable. So in here, we are talking about kinetic energy. Notice that kinetic energy is a scalar quantity. We are talking about energy. Energy is not a vector. So in here, if you think about the total kinetic energy, you should take the full velocity into consideration. So we all know that before collision, we have u for the velocity of p, and again the same number u for the velocity of q. So these are all u's. But after collision, q actually has a velocity of u times cosine theta, and p's velocity, if you do a sum of vectors, you'll find that final velocity vp here is actually u squared times sine theta squared plus vpx squared. And the reason why you have this is because of the Pythagoras theorem, right? You know that this is a rectangular shape, so you know how to calculate the hypotenuse of here, or the diagonal of the shape is actually just follow this formula, just like the formula you have in any right angle triangle. So once you find out this, then you can know that is the total energy, total kinetic energy before the collision for both of the ball. Let's simply use total kinetic energy before the collision should be a half mu squared. Again, we assume that these balls all have a mass of m plus a half mu squared. Now That's the kinetic energy for P. That's the kinetic energy for Q before collision. Total kinetic energy after the collision will be, for P is a half mvp squared. Now remember, Vp will be calculated using the formula, using this formula. That's Vp, right? Plus a half m times the speed of u after collision, which is u times cosine theta. Now, so the question tells you that 25% of the total kinetic energy is lost. So that's basically telling you that only 75% of the kinetic energy before the collision is converted to the kinetic energy after the collision. So only 75% of EK before is now EK after. So the rest of here is just calculation mathematics. And this is 3/4 for 75%. And times a half m times 2u squared. And in here, I just take out a half m out of the bracket. So if you take these out, then what's left in the bracket is u squared plus u squared. And it may seem a little bit weird here, but you will see the reason very soon. Now, Vp squared, we're not going to use Vp here. We are going to use the specific number for Vp. Remember this. So it's u times u squared sine theta squared plus Vpx squared under a root mark. Square plus a half m times u squared cosine theta squared. So now it makes sense because these half m can just cancel out with each other. So on the left hand side, if we keep doing the calculation, and this is actually 3/2 u squared is, and anything under root mark is a square root, so it's powered by 2, then it would just be u squared times sine theta squared plus Vpx squared plus u squared cosine theta squared. Now remember, Vpx is what we have calculated already from the previous question. And this is the Vpx value we have. From the previous question. Now, we simply substitute this to the previous formula. Then we have 3/2 u squared is actually u squared times sine theta squared plus u times cosine theta minus u times sine theta squared plus u squared times cosine theta squared. So in here, the formula, we can do a lot of things. So first thing first, we can take u squared from these two terms. And that's because what left in the bracket is sine theta squared plus cosine theta squared. And this actually gives you a number of 1. If you don't know this, please go back to trigonometry in mathematics, and you will just find out. And 3/2 u squared again on left hand side. So right hand side, you're going to open up u times cosine theta minus u times sine theta squared. So to open this up, well, for yourself, please feel free to do it slowly and nicely. So it's actually plus u squared times cosine theta squared plus u squared times sine theta squared minus 2u squared sine theta cosine theta. If there's anything about here, it's actually this formula came from here. You can simply apply the formula. A minus b squared is a squared plus b squared minus 2ab. Now, following this, you know that it's again 3 over 2u squared. And like we said, it's 1 up. So, and also you can do the same thing for this one. For this one, you can do the same thing, which is u squared. You take off u squared and cosine theta squared plus sine theta squared here, and minus 2u squared sine theta cosine theta. Now here, hopefully you'll see that these u squares just cancel out. Right, so what left here is 3 over 2 is 1 plus 1 minus 2 times sine theta cosine theta. Now again, if you look back to trigonometry, you find out that this is actually sine 2 theta. So now the formula is now 3 over 2 is 2 minus sine 2 theta, and everything should be very clear now. So sine 2 theta should have a value of 1 over 2. And in here, because of theta is an angle located between 0 and 90 degrees, so 2 theta should be located in between 0 and pi. That makes 2 possible values for 2 theta. The first possibility is 2 theta is 30 degrees. The second possibility is 2 theta is 150 degrees. Now again, you got this knowledge from trigonometry part in mathematics. So if you have any question, please just look it up. Right. But for here, I'm not going to use any other time to talk through why I have these 2 values. It's mathematics. Right, anyway, so theta should have 2 different solutions. The first one is theta is 15 degrees. The second one is theta is 75 degrees. Now some people may ask why this matters. Why can't you just take the easiest one? Now this is because the E formula you got from your previous question. The E formula is given by this. It's actually also given in the question. See, the first part of the question tells you that E has a value of tan theta minus 1 over tan theta plus 1. So feel free to use your calculator and substitute theta for this formula. You'll find out that tan 15 degrees minus 1, if that's the first case, you'll find out that this is actually smaller than 0. It's actually minus root 3 over 3. But if you take theta at 75 degrees, then E here should be tan 75 degrees minus 1 over tan 75 degrees plus 1. Now this is perfectly larger than 0, and E should have a value of root 3 over 3. Because e can never be smaller than 0, so we are going to take theta as 75 degrees and e as root 3 over 3. Now this serves as the second part of this question. So for now, we just finished the demonstration of question 4 from the sample paper, Applied Maths 2023. I am Ren Zihan. In English way to say it would be Zihan Ren from Zirconium Academy of Education. And I hope this video can help you out through this type of question. Now, if you have any questions about this video, please feel free to send me a message in YouTube or in whatever the platform is. Right, thank you for watching.